Welcome, everyone. Please give a warm welcome to David Baumgold. He's a freelancer in the Boston area, goes by DB, and will be talking to us about looping like a pro in Python.
All right, hi everyone. Before I start, I want to say in the bottom right corner you can see there's a link so that you can view the slides online during the presentation or afterwards if you want to. So hi, I'm DB. I want to start with a quick shameless plug. As he mentioned, I'm a freelancer in the Boston area. I also do corporate training. So if you like what you hear today and you'd like to learn more, or if you'd like me to work for you, get in touch. So, looping. So let's start with the basics. What exactly is a loop? A loop is a method of programming that allows you to repeat the same action or idea over and over again without repeating code. So again, on a conceptual level, let's see a program that doesn't use loops. This is a program that prints out the word Python, but it does so one letter at a time. And you can see every line does the same thing over and over again. It's much clearer and more concise to write the program like this. We're doing the same thing. We're still typing out Python, but we're saying so in a way where we're looping over each letter of the word and operating on it one at a time while only expressing the display thing once. So we also need to get into a little bit more vocabulary so we all know what we're talking about. In Python, an iterable is anything that you can loop over. So that might be a list of objects. That might be a string where you're looping over the letters in the string one at a time. Could be a dictionary, could be a set, could be a database query, anything where you do one operation at a time. An iteration is one execution of that loop. So in the string Python, p is an iteration, y is another iteration, and so on. An index is a variable that you use to keep track of which iteration you're currently on. And we're going to come back to that a lot later. I also should talk about truthiness and falsiness in Python. If you're not familiar with this, truthy is any value that is either the true Boolean or coerces to true, such as a positive number, or really any number aside from 0, a string with content, a list with content, and so on. Falsy is anything that does not have content, like the variable false, the number 0, an empty string, the variable none, and so on. So, with that all out of the way, let's start talking about how we actually do loops in Python. There are two different kinds of loops. There are for loops and there are while loops, and they're both very useful, but you generally want to use for when you know exactly how many times you want to loop, and use while when you want to sort of keep on going until you figure out that it's time to stop. We're going to start with going over while loops because they're a little bit simpler. You can get much more complicated and much more fancy with for loops. So we'll start simple. This is how a for loop looks in Python. A while loop looks in Python. We have the word while followed by a conditional, which is just a fancy word for a test. We're checking to see if it's time to continue with the loop or if it's time to stop. After the conditional, there's a colon. And then there's the body of the loop, which is indented and can be multiple lines. The body of the loop is what happens while you're looping. So let's take a look at a simple Python program that has a while loop in it. How many of you like going on road trips, especially with kids? So this is a road trip program. We're going to keep on going until we've arrived. And as long as we haven't arrived, the kids in the back seat are going to ask, are we there yet? Are we there yet? In this case, I'm just using the random module to determine if there's a 10% chance that we've actually arrived, but that's not important here. The thing to look at is the structure of the loop here. And I've circled the conditional. In this case, I'm using the not operator to transform the arrived variable into its inverse. So normally, we would check to see if the loop is done. In this case, by saying while not arrived, we're saying keep on going until we have arrived. And at that point, the conditional will be false, and it's time to proceed with the program. So generally, the conceptual model that you want to think about when you're dealing with while is, first, check the conditional. If it's truthy, which is again true or anything that coerces to true, you want to evaluate the body and go right back to step 1. Check again, see if we want to continue. Otherwise, skip the body and move on with the program. So let's go to a different example of a while loop. Here we have a simple task runner, or a task queue worker. And what this worker is going to do is it's going to get a task from the queue, and then it's going to execute that task and get a new one. And it's going to continue fetching tasks from the queue and executing them one at a time. But if you look at this code, there's actually a bug in it. And that bug happens if getTask ever returns none. What if there's no task on the queue? Well, none is a falsy value, so that will cause the loop to exit, which is not what we want a worker to do. We want it to wait until there's a task available. So I'm going to rewrite this code slightly And now it looks like this. Now it's going to continue getting tasks, and if there's ever not a task available, then it's going to sleep for a second and try again. Now you'll notice that I've done here a while true loop. That means that the conditional will never be false. It will always be true, which results in an infinite loop. Infinite loops are usually bad in programming because, by definition, you can't really get out of them. But fortunately, Python gives us some language constructs to be able to customize how we deal with our looping. There are two loop control statements in Python. There's continue and there's break. Continue allows us to skip the rest of the body of the loop and go right back up to the top to continue on to the next iteration. And break says, you know what, actually, I'm done with this whole loop thing. We're just going to break entirely out of this loop construct and keep on going with the program. So let's take a look. Here's our task queue worker, and this time the task queue knows that there are some tasks that it should not handle for whatever reason. Maybe there's special tasks that go to a special worker. So in this case, if the task should be skipped, then we're going to print no thanks and run the continue statement. And that causes the execution flow to go right back up to the top of the loop. We're going to skip the execute task line and go right back up to the top and get a new task, which is exactly what we want in this case. By contrast, what if we have a task queue worker that's a little superstitious and doesn't like the number 13? If you ever give it a task with ID number 13, then it's going to say, I can't deal with these working conditions, I quit. And it's going to break entirely out of processing the tasks and just move on with the program outside of this. And in this case, since the program is very short, it's actually going to exit. So it is actually possible to write infinite loops in Python that actually still exit and are not actually infinite. It depends on the structure of your program, and you can use break to break out of an infinite loop. So that's while loops. You have a while followed by a conditional and a body underneath. We execute the body over and over again until the conditional is falsy. We use continue to skip and go on to the next iteration, and break to break out of the loop and continue on with the program. That's everything you need to know about while loops. Now let's move on to for loops, which are similar but a little more interesting. A for loop looks like this. We have the word for, followed by a variable name, followed by the word in, followed by an iterable. And remember, an iterable is anything you can iterate over, like a list, a string, a dictionary, and so on. And then we have our body, which again can be multiple lines and again is indented. It looks sort of similar. So here's an example of a for loop. We have for num in 1, 2, 3, print num. What this is going to do is it's going to print out the numbers 1, 2, and 3. And we have the variable, which is the word num, and we have the iterable, which is the list 1, 2, 3. If we break this down, it's going to first set the variable num to the value 1, and then run print num, which is print 1. Then set the variable num to the number 2 and run it again. Then set variable num to 3 and run it again. To break it down even further, what we've got here is the way the for construct works is we start by trying to get the next value from the iterable. If we have a value, then set the variable to that value, execute the body, and go right back up to the top and try again to see if we can get the next value. If we've reached the end of the list or the end of the string, then the iterable is empty, and we go right back down to step 5, skip the body, and move on with the program. Now, those loop control statements that I mentioned earlier, continue and break, those work just fine with for loops as well. So if we have our task queue worker, in this case, instead of pulling tasks from the queue, it has a to-do list, and we're operating one task at a time in that to-do list. Once again, if there's some reason why this worker shouldn't operate on this task, then it can use the continue statement to just continue on to the next iteration, skip that task. And if we have our superstitious task runner, then it's going to use break to break out of the task execution, and all the rest of the items on that to-do list will never get executed. So there's one thing that I mentioned earlier that I haven't really mentioned yet, and that is loop indexes. If you remember, an index is a variable that keeps track of which iteration you're currently on. So some languages, like C, use an index variable in order to loop. Here's an example of what that sort of thing looks like in Python. So you have a list of foods, maybe you're going shopping, and we'll create an index variable starting at 0, and then we're going to say while I is less than 3, 3 because that's the length of the list. And for every iteration of the list, we're going to get the food that is at that index of the list and print it out, and then increment the index variable. Don't do this. This is a very common sort of programming style that I've seen from people coming from languages like C or PHP or JavaScript that don't really have a better looping construct than this. A much better way to loop over a list like this is to just say for food in foods, print food. And the reason why you can do this is because Python will automatically bind that variable to each value in the list one at a time. So you don't have to worry about managing an index variable yourself. In fact, this is actually going to be not only clearer, but also faster when you execute the code. So this is the way you want to do it. Now you might be thinking, what happens if I need the list index in the body of the loop? I guess I have to go back to the way that C does it. Nope. Python gives you better ways of doing that as well. So here's an example that uses that index variable. And the result is you're going to get 0 colon bread, 1 colon milk, and 2 colon eggs. So you're looking at this, and you're thinking, wait a minute, there's 2 variables here with a comma, and I don't know what this enumerate thing is, and you're confusing me here. So in order to explain all the things that are going on here, I'm going to take another quick sidebar into another nifty feature of Python called tuple unpacking. And tuple unpacking allows you to assign multiple variables in one statement by using a tuple on the right side of the assignment. So in this case, I'm saying x comma y equals the tuple of 2, 3. And when I check that, I can see that x is 2 and y is 3. Now, tuple assignment works just fine in the body of a loop as well. So I can say for x comma y in 1 comma 2, 3 comma 4. And Python knows that the first value of the tuple should be assigned to the first variable, and the second value in the tuple should be assigned to the second variable. So we still get printing out 1, 2, 3, 4. In fact, if we go back to that description of how for loops work, this is exactly what I talked about earlier. In step 2, we're just setting the variable, or in this case, variables, plural, to that value, or values, plural. So the enumerate function that I mentioned earlier is a very simple function that will iterate through and add an index into each item of a list. So if I have this list of foods, bread, milk, eggs, then when I call enumerate on it, the result is a list of tuples. And we have 0 bread, 1 milk, 2 eggs. And then we can run the program like this. And the execution is set I to 0 and food to bread, and then print out the string. And do it again. I to 1, food to milk, print out the string. I to 2, food to eggs, and print out the string. It's actually remarkably straightforward, and the code is very concise and much more readable than having to keep track of your own index variables. There are a bunch of useful built-in functions that will allow you to loop much more effectively and clearly in Python. So enumerate is one we've already gone over. There's also one called sorted, which will sort a list or an iterable for you. There's one called reversed that will allow you to go over the list backwards. Range gives you a list of numbers, and zip combines lists together. So let's go through some of these. Sorted. I have a list. I call sorted on it. In this case, it's just going to sort it alphabetically. But it will also sort based on numbers, and you can even provide custom comparison functions to sort exactly the way you want. Check out the Python documentation for more. Reversed does what it says. Instead of getting bread, milk, eggs, we've got eggs, milk, bread. Pretty straightforward. Range is handy when you want to count up numbers. So in this case, I can say for num in range 5, and it will give me an iterable of 0, 1, 2, 3, 4. Again, you can customize this by saying where you want it to start, where you want it to end. You can even ask it to count by 2s or by 3s or whatever step you want. Check the Python documentation for more information. So, some of you might actually get into a situation like this as well. If you've ever needed to loop over 2 lists simultaneously, people often reach back for that sort of C indexing method. And the reality is, you don't need to do that. Because if you want to loop over multiple lists, this is how a lot of people do it, by saying, I need to say Alice likes milk, Bob likes eggs, and Carol likes bread, but you don't need to use this index variable. Instead, you can use the zip built-in function to combine those 2 lists together. And we get exactly the result that we're looking for. Alice likes milk, Bob likes eggs, and Carol likes bread. The way that zip works is if you give it multiple lists, it's going to combine them together like a zipper. adding each element of the list into a tuple of all of the respective lists combined together. So zip of people and foods is going to give you the combination of Alice and milk, the combination of, Alice and bread, combination of Bob and milk, and the combination of Carol and eggs. You can even combine together more than 2 lists. There's no limit. It's just whichever lists you pass into the zip function. So that's the for loop. We have, the structure is for variable in iterable, followed by an indented body of as many lines as you want. It's going to set the variable to the next value from the iterable and execute the body, and continue doing that until the iterable is empty. And you can also modify the iterable using functions, such as enumerate, sorted, reversed, range, and zip. So that's all the beginner stuff in this talk. I'm going to get into a little bit more advanced stuff as well. It's often a problem where you have to have multiple loops nested together. So in this case, we have a group of people, and you want to have people greet each other from that list of people. So this sounds like a good case for a nested list. I'm going to have person 1 greet person 2. But the problem with nested loops is that frequently the logic starts getting a bit more complicated. So for example, you can't have a person greet him or herself. So I'll stick in some custom logic here to say, just skip that case, just continue. You might have people in the group who are antisocial and who they're willing to respond to someone else's greeting, but they don't want to actively go out and greet someone else. So I've got that logic in here too. And then there are some people that just really can't be in the same room as each other. And if they ever have any sort of social interaction, a big argument breaks out and all communication in the room stops. So we want to model that by using a break statement. But the problem here is that this break will actually break out of the inner loop, but not out of the outer loop. So we have here a situation that we want to model in Python, and this doesn't do it the way that we want. How do we deal with that? Well, to improve complicated nested loops, you can actually use something called generators, which are another handy feature built into Python. Now, generators are its own talk all on its own, and so I'm not going to get too far deep into them. I just want to talk about how you can use them to refactor nested loops. Here's an example of using a generator to reconstruct that milk, eggs, bread list that we had before. I'm using the yield statement to yield 1 value at a time. And then in the loop that's below this, I'm able to get each of those values 1 at a time from calling the grocery list function. So this is just another way of designing iterables, as I talked about earlier. Now in this case, I can use a generator to separate the logic of my loop from the body logic. So I've defined a new function called pairs, which is going to yield pairs of people from this group. And then below that, I have my for loop where I'm processing person 1 and person 2 and having them greet each other. Now, I can take those same pieces of complexity and introduce them into the pairs function 1 at a time. And the actual processing that happens stays separate and is much easier to understand where the separation is. In addition, you can use the return statement to break out of a generator early, and that doesn't have the same limitations of the break statement. When you run return, that ends the generator entirely. So that allows you to do the same sort of situation that I described earlier but wasn't able to do using the break statement. You can also use generators to avoid work. Generators are evaluated lazily only when the work is actually requested. So if you have a lot of potential work to do and you only end up needing to do a little bit of it, that can save you a lot of time and make your code run faster. So here's an example where I'm using the range function to get the first 10 million integers. If I do it lazily and don't actually check those integers, then it takes me less than a microsecond. But if I actively evaluate all those integers, it takes me 40 milliseconds, which is 10,000 times slower. So if you think you might not be using all of your work in all of your generators, then don't bother. Just let it happen lazily. As I said, there was another talk about this. Similarly, if you have a database query, you can make sure that you only use the items from the database that you're actually going to process. In this case, the code will only load the first 10 users if you've got lazy database queries, if you're using generators. If you were to turn that into a Python list, it would try to load every user in the database, even though you're only using the first 10. You can also use generators to create infinite generators, such as this road trip thing that we were talking about earlier. But this is actually occasionally useful, and here's an example where you can use it. If you have a paginated HTTP API, like what you might get from GitHub, then you can write a generator that will make HTTP requests for you in the background to load objects from the paginated API, and your code that needs to use those objects can just treat it as an infinite generator. It doesn't have to worry about all that complexity. So you can just say for widget in get widgets, process them. So it's not only more efficient because it only loads the widgets that you need, but it's simpler to understand as well, which is great. So generators are very useful for refactoring nested loops and for separating the iteration logic from the loop body. They'll also give you performance improvements if you find yourself in a situation where you have more items in the backlog than you actually need to process. And infinite generators can be occasionally useful, particularly when you're dealing with paginated APIs. Now, there's one other thing that I want to go into this talk, and I have very little time left, so I'm going to try to cover it quickly. There's a module in the Python standard library called itertools, which is amazing for doing advanced iteration techniques. I can't go over all the things in itertools that make it really cool, but I'm going to go over two. Remember that thing we talked about earlier with people greeting each other? That is a mathematical construct called a permutation. You have a group of people, and you want to find every unique pair of people in that group. Itertools has permutations and combination support. So in this case, I can just say pairs equals itertools.combinations, and it will do all of that logic for me. Although, of course, if I'm dealing with antisocial people or people who really can't be in the same room as each other, I'll have to implement that separately, but that's another matter. There's also a really cool function called itertools.groupby, which is really handy for cases where you want to display lists of people with headings of the different sorts in that list. So let's say, for example, you have a database that has school children, and you want to make a web page that lists all the kids in your school, organized by grade level, with a heading between each grade level. So you say, you know, grade 1 is Adam, Bob, Sally, grade 2 is Frank, grade 3 is Alice, whatever. So this would normally require doing that sort by grade level and then detecting where you get that change in between grades and stopping your iteration and sticking in a header to denote the difference there. But with itertools.groupby, you can do it much more succinctly. So here's my database query to get all students ordered by grade level. And now I'm going to use itertools.groupby to group this list by the grade level of each student. So the output of just the database query would be a list of students, but the output of itertools.groupby is a list of tuples, where each tuple is the grade level followed by the list of students in that grade. So this means that when you get to the point in your code where you want to actually display this, the logic is very simple. You can just say for grade in grades, or for grade comma students in students by grade, and print out the heading, and then do a nested loop to print out each student that's in that grade. It becomes much easier to understand and faster as well, because there's less logic to understand. There's less logic to run, and there's nothing faster than not running the code at all. So I've gone over a fair amount. These are all the topics that we talked about. Does anyone have any questions? Go ahead.
Hi, so I'm new to Python. I'm trying to be Pythonic, but I do come from the C and even basic world, and maybe Pascal, if you've ever heard of that. And so it was beat into me not to do the break, and like continue wasn't something I either ever learned or existed. So do you say that break and continue is very Pythonic? Is this a desired thing, or is it a shortcut so we don't have to have a couple more lines of code with the flag to exit out of our loop?
Break and continue are used to solve specific problems. If you run into a case where you find yourself reaching for that tool, then that may well be the tool that you need to use. Now, if you find yourself littering your code base with these statements, then maybe you're actually making it harder to understand, and maybe you should look into refactoring your code. But in all the examples that I showed earlier, break and continue seemed like the right tools to use, and there's nothing wrong with using them. They're not anti-Pythonic or anything like that. It's just use the right tool for the job. One other question over here? Maybe? Anyone?
Thank you, David.
Sure. Display thing once. So we also need to get into a little bit more vocabulary so we all know what we're talking about. In Python, an iterable is anything that you can loop over. So that might be a list of objects, that might be a string where you're looping over the letters in the string one at a time. Could be a dictionary, could be a set, could be a database query, anything where you do one operation at a time. An iteration is one execution of that loop. So in the string Python, p is an iteration, y is another iteration, and so on. An index is a variable that you use to keep track of which iteration you're currently on. And we're going to come back to that a lot later. I also should talk about truthiness and falsiness in Python. If you'd like to learn more, or if you'd like me to work for you, get in touch. So, looping. So let's start with the basics. What exactly is a loop? A loop is a method of programming that allows you to repeat the same action or idea over and over again without repeating code. So again, on a conceptual level, let's see a program that doesn't use loops. This is a program that prints out the word Python, but it does so one letter at a time. And you can see every line does the same thing over and over again. It's much clearer and more concise to write the program like this. We're doing the same thing. We're still typing out Python, but we're saying so in a way where we're looping over each letter of the word and operating on it one at a time while only expressing the Python. If you're not familiar with this, truthy is any value that is either the true Boolean or coerces to true, such as a positive number, or really any number aside from 0, a string with content, a list with content, and so on. Falsy is anything that does not have content, like the variable false, the number 0, an empty string, the variable none, and so on. So, with that all out of the way, let's start talking about how we actually do loops in Python. There are two different kinds of loops. There are for loops and there are while loops, and they're both very useful, but you generally want to use for when you know exactly how many times you want to loop, and use while when you want to sort of keep on going until you figure out that it's time to stop. We're going to start with going over while loops because they're
Welcome, everyone. Please give a warm welcome to David Baumgold. He's a freelancer in the Boston area, goes by DB, and will be talking to us about looping like a pro in Python.
All right, hi everyone. Before I start, I want to say in the bottom right corner you can see there's a link so that you can view the slides online during the presentation or afterwards if you want to. So hi, I'm DB. I want to start with a quick shameless plug. As he mentioned, I'm a freelancer in the Boston area. I also do corporate training. So if you like what you hear today,